Welcome to AP Stats Quideo number 6. This question discusses the difference in mean wait time of patients who express symptoms of a heart attack and the difference in their mean wait time based on whether they take an ambulance to the hospital or they have some sort of self-transportation there. Part A asks you to use a 99% confidence interval to estimate the difference between the mean wait times for ambulance transported patients and self-transported patients in the emergency room. So here I have my whole sort of confidence interval. So starting off with the P of pants, we're talking about the parameter. So mu of A is the mean amount wait time for patients who take the ambulance, and mu of S is the mean amount wait time for patients who take themselves to the hospital. And we use that because we are comparing the wait time based on whether you took the ambulance or you went your own way to the hospital. And then A, our assumptions. We are told in the question that this is a random sample and both samples are above 40, so the central limit theorem applies and we may proceed and assume that it's normal. And we know that it's above 40 because the sample size for people who took the ambulance is 77 and the sample size of people who use their own self-transportation to be 73. And this is going to be a 2-sample T interval, and it is 2-sample because we are comparing two different samples: the sample of the ambulance or the people who use the ambulance, and the sample of people who take themselves to the hospital. We know that it is a t-test because it gives you the standard deviation of the sample, but it does not give you the standard deviation of the population because it has that on the chart right there. And we know that it's an interval because it asked us for the confidence interval. So this is what the formula looks like for a 2-sample T interval. So it's x bar of A minus x bar of S plus or minus T star times the square root of the standard deviation of A squared over the sample of A plus the standard deviation of S squared over the sample size of S. So, and well, A stands for ambulance and S stands for self, by the way. So then when you go to test it out, you fill everything in. So you get the 6.04 for your x bar of A, and you get that from here, your mean wait time for ambulance. And then you do the same for self. So it's 6.04 minus 8.30 plus or minus 2.04. That's what you get after you plug all this in, and that's going to be your margin of error. But we get all this stuff from this. Well, this is from the yellow sheet, and it talks about degrees of freedom. So you get degrees of freedom by taking your sample size and then subtracting 1. So our degree of freedom would be 150 minus 1. And we know that it's 150 because it says in the problem, sample of 150 patients. So you get 149. And so we know that we are finding a 99% confidence interval, and our degree of freedom, or the value we're looking for, is 149. That was our sample size minus 1. But we can't go over, so we're going to look at 100. We're going across all the way to 99, and we get 2.626. So that's where you plug in your degree of freedom, or your T-star value. So we have that plugged in right there, times the square root of 4.3 squared over 77 plus 5.16 squared over 73. And again, we get all of these values from this chart. Sample size 77 and 73, mean wait time 6.04 and 8.3, and the standard deviation 4.3 and 5.16. So those are all kind of plugged in here in different places. So, like I said before, this is going to be your margin of error. And when you plug all of it in and you calculate it all out, it's 2.04. So that's your margin of error, and that's one extension that you can make. Now, when you do plus or minus, your interval is going to be between negative 4.3 and negative 0.22. So, based on the sample, we are 99% confident that the true difference in population mean wait times is between negative 4.3 and negative 0.22 hours. Therefore, we can assume that the wait time for patients who take an ambulance is shorter than those who drive themselves. Part B asks, based on only this confidence interval, do you think the difference in the mean wait times is statistically significant, and then to justify your answer? I think that we can reject the null because a difference of 0 minutes is not within the 99% confidence interval. We would reject the null that mu of S minus mu of A equals 0, and that there is strong evidence that at a 1% confidence interval, mu of s is larger than mu of a.